Hi, I'm Sam Harris. I'm the project manager for Aviation Technical Design 1 and 2. And I am standing here with Mr. Kevin Kimball at JKE Works in Mount Dora, Florida. There's Kevin's son, Cal, straight over there. And this is all part of Module 2 for ATD2. And what it is we are actually fabricating, taking a real world problem, fabricating the part out of the Lockheed Vega, which is right here, which we're going to learn a little bit more about. But more on that, it's time for me to stop talking and time to invite Kevin. Kevin, if you could just give us the background on how you got to what this problem is and how you solved it and all the rest of the stuff that would help us out.
Yeah, welcome everyone. We're in the business of restoring antique airplanes. So we take whatever it may be, like this particular Vega's 1929. We specialize in wood and fabric type airplanes. And as you can imagine, airplanes that are 90 and 100 years old, you can't just go to the store or aircraft spruce and buy parts. You need to make some things, and you're going to have to repair parts that otherwise you probably would have thrown away if you could, but it's the only one in existence, so you have to fix it. So we have a lot of that we have to do. In this particular case on this airplane, we've been fortunate to get a lot of the original factory drawings. So we have the data to know what it's supposed to be so that we can put it back. And so many of these airplanes have been heavily modified over the years that some of the pieces are damaged or cut or lost, and we need to replace them. So in this particular case, all the wood you see here has been replaced because the age of the wood. And then some of the fittings most of the fittings here are actually original parts. And we're able to reuse them, check them with all today's inspection procedures and everything else. Yet some were lost or broken, and in this particular case we had some pulley brackets that we needed to have, and they didn't exist anymore, but we had the data, so we had to go ahead and create those and make those.
So can you tell us, when it comes down to something like this, okay, you get the airplane, turns out that most of it's not going to be usable. You don't just go out and start bending metal on a workbench or anything like this. What is the process by which you realize that you have to duplicate this part? How do you get to that point where you're actually able to duplicate the part? What's the process by which you do that?
The first thing is to know what the part is, what it has to be, what it needs to be made of. Lucky for us, in this particular case, we were able to get the drawings for it, the original 1920s factory drawings. So that gives you all the information you need. You know what the material is, you know how it was made, if it was cast or machined or folded, you know everything. So we're able to use that to then look at what manufacturing techniques can we use today. In this particular case, on a piece like this, we could have made models and cast it and then machine the casting, or we can just machine it from equivalent materials that were used. And because you need one part, it's not very cost effective or time effective to go through the casting process.
Right.
It's more efficient to go ahead and machine it, and it's less costly in the end for the customer because the labor would be quite high doing it the other way.
Now, back in 1929, when it came time to make this part, help me out here on the casting. Did some artisan carve it out of wood, and then they said, yeah, that looks about right, and then they made a mold, and then they poured aluminum into the mold? And
correct.
Is that how that worked?
Yeah. So this is a part for a different airplane, but it is a cast part, and you can see all the lumps and bumps in it, and it looks like it has almost a sand texture to it, and that's because it was actually a sand casting. So a casting, basically an artist, a carpenter, a tool maker, would look at the drawings from the engineer, and he would carve this out of wood. And it might be made out of a dozen pieces, depends on what it is.
Right.
But they make that, and it becomes the master shape. And then they take that and put it in, pack it in sand, in a special sand for doing sand casting. They pack that sand into a top and a bottom half mold, and then separate the mold, take the piece of wood out, and that leaves a sand-shaped cavity, and then put it back together, pour the metal in, and now you have the part.
Right.
That's how it was done. And it's really good for production work. We've got to make, you know, if we're gonna make, this was a Stearman part, they built 15,000 of these in World War II.
Right.
So this particular part, they probably made 30 or 40,000 of these. So
Right.
the setup might have had a dozen or 50 of these in the cast that they poured all at one time. So it works pretty fast.
And the sand that they, you know, this, we're not talking about beach sand here.
No, it's made for the casting process, special.
Yeah, it's kind of a clay
Yeah, and
kind of.
it'll pack and it will hold shape.
Right, right,
So
right.
it's more like if you're doing the sandcastle with the wet sand and everything takes shape.
Right.
It just, it doesn't have water because of course, all this is happening at thousands of degrees, so
Right.
the water, you know, will go away.
Okay, and then you pour the aluminum in, the aluminum cools,
Yeah,
you break the cast apart.
just knock the sand off of it. Now you have this string of parts that are all connected, kind of like a plastic model with all the
Right.
little trees on them, and then dress them out from there. But it's not finished. Then that part still needs to go in and be machined.
Right.
So even if you start with a casting, then these holes had to be drilled, the faces had to be spot faced, the hole for the bearing had to be machined to the proper size. So there's a lot of work that still has to happen as secondary operations.
Right,
So it's really just a way to get close to the part size that you need, save aluminum in this particular case.
right,
Because you're not starting from a big block, and then be able to produce the parts in mass.
right. And every cast part had a sand casting that was one-time use, right?
Right. The tool, you know, the pattern is what they
Right.
call it,
Right,
would be reusable.
right,
And you would, so they would set up, and as I mentioned, maybe they had 50 at a time. They had 50 of those things all carved out with sticks that aligned them, and they put that in the sand, and they'd pour all that at once. So they could reuse the patterns, but the sand was one time.
and now in the case of this part, nowadays, we just kick it out of a giant machine, like this. This is a 4-axis mill that, JKE and Kevin and Callan work with right now. They go ahead and, they design parts like this.
Yep.
Which is the equivalent of that pulley, which we'll see here in a second, but this part, you know, the original part was sand cast, and then it went over to machining.
Right.
You know, and the machinists went ahead and machined the part, but now it's easier for you. You guys use SolidWorks, I think, or CAD, just as good as Fusion 360, or actually vice versa, probably more accurate. And then, you know, you upload the program in, and the 4-axis mill will punch that out in one shot, right?
Yeah, we can do that in a one and done on the 4.
Right.
This particular one was done on a 3-axis mill, so we actually, instead of doing it as a one and done, we actually did 4 setups. So initially it was in a block of aluminum, sit this way, did the work on this side, turned it over, did the work on this side, laid it flat, did the work here, and then finally cleaned off the bottom.
Okay.
So that's basically doing the same thing as you would do with a 4-axis, it's just the 4-axis does those rotations for you instead of having to manually do it, positioning the part in the vise.
Now, when we look at the blueprints, John, could you get a hold of this? When we look at the blueprints are just a little bit different here in that the shape of this fork here, this is a circular shape, whereas Kevin, you guys have gone and turned this into obviously a little bit more robust shape, a little bit U. Can you explain to us why you chose to make that decision?
Sure. Yeah, originally that would have just been a full circle pad here and wouldn't have this extra little thickness of material down here at the bottom. And the reason we did that is to make it a little bit easier to machine. As a casting, it's easy to do that because that sand won't get trapped on the part and it can fall
Right.
away. When you're machining this and you have it in the machine like this and you're approaching with your tools this way, you can't get to cut this material off down here if your tool is only oriented in a vertical direction like that.
Right.
So by leaving this material on, we made it a little bit easier to manufacture. So that's a feature you would refer to as design for manufacturability.
Right.
And in this particular case, it adds a little bit of material, which is grams of weight, which is non-critical on this airplane.
Sure.
And it didn't make didn't
Right.
weaken the part, compromise any performance at all.
I would imagine if anything, it's a little bit stronger.
It would be just a little stiffer in that area.
Yeah, yeah. Now, okay, so would you mind showing us where
Where it
this
is?
part came out of?
Yeah. So in this Lockheed, 1929 Lockheed, the control systems are all cable actuated. So the linkage from the cockpit to the tail feathers to the wing and the ailerons are all by cable. And so each of these cables have a purpose. We've got rudder cables, elevator cables, and this pair in the middle is the horizontal stabilizer trim actuator drive cables. So there's 3 pulleys here, 3 pulleys here, 2 pulleys here, a total of 8 in this station for the change of direction of these cables. The reason in airplanes you use pulleys is if you have a straight line run from one point in an airplane to another, you don't need any pulleys. But this has to turn and bend up, and you can see how the cable runs up to the next station here. So that's why you need a pulley, so it can change direction. This bracket was lost. So it wasn't with the airplane anymore. It had been lost somewhere in its life, and so we needed to replace it.
Were they using something in its place, or I know when you got the airplane wasn't flying, but did somebody kind of jury rig something in there?
The airplane was used for some specialty testing in the 50s, and they actually took out this cable system for the trim and put an electric motor on the trim actuator and used wiring and a switch in the cockpit. So it was modified to the point where it's not correct for the original design, and it doesn't meet the original design specs, so it's really not an FAA approved acceptable method to have that electric trim. So we need to put it back to the original.
So the aircraft, so you just make the aircraft experimental and you get away from...
Right, it was an R&D airplane at that time.
So let me ask you this then. So why didn't they just leave the pulley in there?
They took out everything they could to save weight and to also, that particular job that it was doing, this is an all-wood airplane, so it has a very small radar signature. And so any piece of metal in it added to the radar signature. So any pieces of metal they could throw away, that's what they did to make it small radar signature. So GE was improving their radar systems with this airplane. Using a 1929 airplane in the 50s to try to be better with radar, be able to track smaller objects.
It was a stealth airplane in the 1950s.
Correct.
Yes.
Yeah.
So very good.
So that's what it's for. And then part of that control system that we're putting back in the airplane, get it all original.
Now, what's the fidelity of this? How important is it that you make this part correctly? I mean, is this is this airplane going to fly if that part breaks in flight? I mean, how much do you worry about how good the part is?
Well, we have confidence in the original design. It is a certified design, so we know that. And in this particular airplane, it flew with these parts in it for 16 years, so chances are it's going to work. So we don't have concern there. Our ability to recreate the parts, whether it's from wood or aluminum, whatever, steel, whatever the parts are originally made from, our ability to build the parts according to the original factory drawings is really the variable. So whether it's we're doing it or somebody restoring an airplane just like restoring a car. So you have to know what to do, how to do it, and to do it right. And it's just years of us doing this, we had the experience.
Is this a better part than the part that was on there back in 1929?
Yes, because the metallurgy is better today than it was then. The actual alloy they were using back then in 1929 isn't even produced today, and it's been replaced a couple of times with improved alloys that are structural equivalents, but actually work better in the manufacturing process, and they're actually a little stronger.
So help me out here. Okay, the metal's a little bit stronger. Is it a little more ductile maybe? Is it lighter? What do we got going on for us?
Ductility is about the same. A lot of times castings are quite brittle, but this particular material that they used was actually quite soft. So we've actually had some of the pieces where they were bent and we're able to straighten them, even though they were a cast part.
Was that an engineering decision, do you think, or was that just what they had to work with?
It's what they had to work with, and some material out. At this time, today, it's rare for an aircraft manufacturing facility to do their own castings. they'll design the castings or forgings, whatever it may be, and they send it all off, and somebody at some factory does all of that stuff, the dirty, messy stuff, and it comes back as a chunk, and then they maybe machine it, do the finish work at the factory. Lockheed was doing everything in-house. So the only thing they didn't really make were the bolts, and they didn't grow the trees. But they took bulk lumber, turned it into the wooden pieces that they needed. They took raw materials of the aluminum and poured their own castings, did their own machining, everything.
You made this out of aircraft grade aluminum, there's a billet of it over there. But I'm just wondering, if the materials, if honoring the materials, which is obviously both important to a couple of old guys like you and me, but if honoring the materials wasn't as important to something like this, is there a material that would carbon fiber make a better one of those, or is that really the ideal material for what you're trying to do?
This is, I mean, staying with aluminum is ideal. If we wanted to change the material completely from aluminum to carbon, or even take this wood and go to carbon fiber, that turns it into a completely different airplane. It's no longer the airplane by design that it was. So it can't be the airplane. So in this particular case, we have to use the materials that were used originally, with the exception of, there's still aluminum, but we can use an improved alloy.
Right.
So we can use, for instance, some of the steel parts in this were 1025 steel. That's the alloy that was used, which is quite soft and about the strength of common mild steel today that you might just see at an angle iron at the hardware store. But we can use 4130, which is a very well accepted aircraft grade steel in the same positions, and it's actually a stronger part because the material is better, the technology is better on the materials. So this particular alloy here does the same job as the other, but it holds up better.
Okay. So it's still a Lockheed Vega, only more so.
Sure.
Yeah. You hear that? Carbon fiber is not always the answer. Right. Maybe we'll go over to your office real quick, and maybe you could show us about how you kind of got us to this point.
Sure. Yep.
All right, great. So we're here in Kevin's office, and Kevin, I just wanted to ask you, so all right, we've established that we're going to get to this part here. Mm-hmm. But it all has to start somewhere, right? So someone comes in, hands you an airplane that clearly is not going to fly, that you're basically going to have to rebuild. And it's not like you can go down to the corner bookstore and buy a set of plans for a Lockheed Vega. So how do you take us from the thing rolling up in the grass to I have to design this part? How do we get there?
Well, in this particular case, as I mentioned before, we're pretty fortunate that we were able to get a lot of the factory drawings. We have close to 3,000 factory prints. So we actually have the factory drawing for this part.
I have to interrupt. Where did you find them?
These from 3 different collectors plus 2 museums.
Okay.
So it's multiple sources. And it's one of those things where those drawings were, let's call it outside captivity.
Okay.
Because in the 50s and 60s, Lockheed was still supporting these airplanes in the field. So they would just give out copies of drawings for people to be able to do repairs. So in this particular case, I think I have the print. Let's see here. But so this is a scanned copy of that particular drawing. And what's interesting is, a lot of people don't really realize the history. They see a lot of drawings that are white paper with black lines or white paper with blue lines, and those are blue line drawings. This is when people talk about blueprints, this is a blueprint.
Right.
And it was hand drawn on paper and pencil, and then this is actually an early version of photocopy to do this.
This is the old mini machine.
The ammonia was the cure on the paper, so it made like a negative, and that's why it comes out blue. And part of the issues that we had to deal with, as you can see, that this says it's part number 2004 in handwriting here. I have it labeled as 32,004 because that's the later part number, but the actual original part number was 1A6075.
And whose copy was this?
This was in a collection in California.
And is it an engineering copy, a copy for the quoting office? I mean,
this as dirty as this is, I would say this was a shop copy. But if you notice, This was drawn on February 7th, 1928 by Gerald Volti, and then it was approved on the 8th of February 28 by Jack Northrop, who later founded Northrop Aircraft.
So for our students out there, okay, a little side project. Figure out who figure out who Jack Northrop was, and what was Volti's first?
Gerald Volti.
Gerald Volti. So figure out who Gerald Volti was, what the name of his company wound up being, and then find 2 airplanes that they wound up building, and 2 airplanes that Northrop wound up building.
Yeah.
Okay.
So, what's interesting, I don't even think that you and I have discussed it, is there's a note on this print right here, and it says, make this bracket by cutting down casting number whatever 6204. And that particular casting is one for 3 pulleys instead of 2. So what they had you do is they cast, as we were talking earlier about the casting,
Sure.
They actually cast the 3-legged version, the 4 legs, so it'd have a 4th leg. And then they just go to the bandsaw, cut it off, grind it, drill another hole, and make this one.
How about
So that's how this particular part was made.
That was a practical way to handle it.
Right.
All right. So you get the blueprint, and now what our students are doing is they're taking your blueprint and they're wondering, how real is this, right?
Right.
So you take that blueprint and you actually go and you CAD up the part yourself.
Right. Yeah, let me get whatever's going on there to stop. Open that part. So here's the CAD model that I created of the part. And you can see here, I made it with the full round here, just as the original part was, not this way that we actually machined it.
Right.
We added that material here to make it easier to machine.
So that was a machining decision. That happened at the machine, not on the computer.
Actually, well, I've done it on the computer on the machined part
Okay.
CAD file.
Okay.
This is on a lot of the stuff I'll model it exactly to print, and then we say, okay, well, we have to make this adjustment, so then I have a rev version that has the adjustment on it.
Now, when you make an engineering decision like that or a machining decision like that, does that inherently change the part as far as the FAA is concerned?
No.
Okay.
Now, one thing that's interesting about these particular parts is that, unless otherwise noted, the tolerances are plus or minus a 1/16 of an inch. So it's a little bit hard to see right there, but it's limits plus or minus 1/16 of an inch unless otherwise specified. So in this particular case, there's no specification that says this has to be within 2/1000ths of that exact dimension. It's plus or minus a 1/16. So this isn't quite a 1/16 of an inch thick.
Right.
So I'm still within spec of the drawing.
Okay.
This still conforms to that drawing.
I'll have to pass that on. We didn't pick up on the 1/16 of an inch tolerance for this. So.
And so the other thing here too is, if you consider that this was a casting, it would have had, there's no draft drawn in this part. It's just straight up, parallel sides, just like we machined it. So
Right.
we conform to the print. But when they actually made the casting model of this, anytime you cast something, you have draft, which is where there's a taper in all the sides. So it actually would have been about a 3-degree taper on every side. So it'd be thicker on the bottom than it is on the top.
Well, that makes sense.
And that made it easier to come out of the mold.
Sure.
So when they're taking that sand apart from their wooden carved one, and they're pulling it apart, if it's all straight, it's kind of locked and it won't come apart. So it's kind of like if even if you mold candy, it's the same sort of thing. So this particular case, we still conform because they had the tolerance that loose to allow the artist who was carving this to use his knowledge and know what to do with all that.
Now, let me ask you this. I can't help but notice, and I don't want to embarrass anybody here, but I noticed that there is an imperfection here in the bottom.
Yep.
Okay, is that intentional? And if it isn't, is that the reason why there's a second part?
Yeah, that was a part shift. So it actually shifted, and we ended up with a tool path that trimmed the edge a little bit the way we didn't like it. And so we didn't. So this is, functionally, this would be fine.
Because it's within tolerance.
Sure. But basically what happened is that when we're doing the deburring, the chamfer, running the 45-degree chamfer tool around here, on this particular one, it got on the wrong side of the line.
I see.
So it ran up the wrong side of the line. and that was me clicking on the line the wrong way.
Okay. Could you show us the Vega again, the
Sure.
larger cab model, the Vega?
Yeah.
Now it's you and Callan running things here.
Yeah.
I'm just curious, how much of what we're looking at is because you needed to do it, and how much of what we're looking at is, well, I've come this far, I think I'll just, finish catting this thing up? Or, I mean, is there more, or is this all of it? I mean, where are we at?
This isn't all of it. I have more than this that we've done. Primarily, we've done CAD work on the fuselage control systems. We haven't done any CAD really on the tail or the wing, because those components were in really good shape and they're 85% original
Okay.
on everything, and we repaired those. So, to answer your question, I haven't bothered drawing it if we don't need it.
Okay.
So,
And,
just what we need.
all right. And, let's see.
So we'll actually, I have the seats modeled in here, the seat frames,
Sure.
because we have to make all these mounting brackets that make up the seats. And what you're seeing here ghosted in is my block of aluminum
Okay.
that will be machining
That
that
was my
particular
next.
part.
Okay, so that's the size of the.
So we'll start with a block
The
that
block.
big. We'll hold it in that 4th axis vise over here.
Sure.
We'll do the machine work, turn, and then it'll end up where we finally part them off and they drop free as parts.
About that. I'm going to ask this for the students because I know they're going to ask, is that a toilet I see back there?
That is. Yeah, this airplane was the, zoom in on it. This airplane was the first airplane built by Lockheed ever that had an executive interior in it. So it actually has a fold-out desk here that folds out and goes to the other side, extends across, filing cabinet doors here.
And who was
the
that
toilet.
desk? Who was that desk for?
The secretary.
That's right, because the secretary went flying along with the big
Yep.
cigar chomping CEO.
And you see this is the oil tank in here, which we have the original oil tank. And this notch that's cut out in here is the storage bay for the typewriter. The typewriter sits here until it needs to be brought out and placed on the desk, and typing will be done. So this is the very first, one of the first airplanes to have a toilet, things like that inside. There were some of the airliners did, but as a corporate airplane that this was at the time, that's pretty innovative for the time.
You and I are pretty close in age.
Old?
I don't know. Yeah, older than our students, that's for sure.
Right.
Let me ask you this: do you still enjoy doing this?
Absolutely.
Do you still,
Yeah.
is it still kind of, I don't know about you, but for me, it's almost like therapy. It's almost relaxing
yeah.
to sit
Yeah.
down and do some CAD work.
So I was drawing some parts at 3 o'clock this morning. So
Okay. Unfortunately, we have the same DNA.
right.
Let me ask you this. Obviously, they didn't have this, unfortunately, back in 1929. But if you want to do anything along these lines in any kind of aviation or anything like that, and you have a certificate that says just use, not an expert, but just a user level in CAD. I know what a chamfer is. I know what a fillet is. That kind of thing. As opposed to, I don't. Right? I mean, how important is that to you? Do you even care?
I do, because to me, it's important for someone that we're working with or helping do something, even if it's not a project of ours, that they understand the language, they understand how to ask the question.
Sure.
So, what CAD brings more so than just the documentation. It's now you have it forever. It's saved.
Yeah.
But it also is such a communication tool, to the point now where we can the models contain all the information that you as a designer or a draftsman need to convey. And if you're going to be a person who's going to want to manufacture that, you need to understand enough about how this stuff works to be able to have that conversation. So it's super vital and very important.
When you send, you can clearly manufacture most of your stuff here, but when you do send something out for manufacturing that you worked up in CAD, how much additional conversation, phone, email, how much information has to change hands between you and whoever's going to fabricate that part for you before it's good enough to go on that airplane?
It varies, because it'll vary with who I'm working with. I have vendors that can make stuff for me that I can send them just the raw CAD model, no dimensions, no prints or anything, and get back exactly what I want. I have vendors that I can send every bit of information that I can dream of, and you and I brainstorm over it and get every note possible, and still not get everything that we want.
Sure.
So it really is dependent on the other side. It's like most communication, as you as an instructor know, the whole game is to figure out what to tell someone to be able to get the answer back that you need.
Right.
And each person, each company is different. So there are commonalities, and there's languages that we use, whether it's English or CAD or whatever it may be. But understanding and making a relationship with a vendor so that you guys are compatible is what's important. So some of the parts that we need to make here, we make using the CNC machine. This is a Haas 4SS, and it's a vertical milling machine, vertical machine center. So it's a 3-axis machine with 4th axis rotary on it. This allows us to make most any parts that we need here out of various metals: steel, aluminum, magnesium, whatever we need to do. And we use it quite a bit. We've used it for our parts in the Vega and other airplanes. And Cal's going to show you a little bit about how it works.
So it's a 3-axis CNC milling machine. Let's go ahead and kind of wake it up here. So we have, this particular machine has 50 inches of X. We've got 20 inches of Y, 25 inches of Z. It's quite a big volume we can build in. We also have a 4th axis rotary on here. So we can do a lot of stuff in one particular little spot, like our part. Let's move this up here. So we can, the trim pulley bracket we can build on a vise in 4 setups, or we can stick it in the 4th axis and have this rotate while we machine. So it kind of allows us to have one setup versus maybe 4 or 5 for one part. So this is a 1/4 inch ball end mill in the spindle here. So that's for some of the stuff we've used here. We'll do a tool change real quick so you can see it. What this particular machine does, it changes the tool. We'll have to close the doors. Typical little three flute end mill, pretty sharp, uncoated, and I think we can run this one about 12,000 RPM, and we could do probably 300 inches a minute on cutting aluminum if we want to hear the noise. But it's pretty good machine. Turn on some coolant for the machine so it has built-in coolant, so we can run as we're cutting to keep everything cool and lubricated, and kind of washes away the chips as it cuts. And it's all contained inside the machine and not all over the floor. So it does the lubrication for the part. It's got a little bit of oil you do to it, but it's the lubrication plus.
I'm going to go out on a limb and say you're an aviation nerd. Okay.
Born and raised.
Yeah. Okay. So I was wondering, what advice would you give? And this will be our last question. Mm-hmm. What advice would, if you could find your 16-year-old self in the year 2023, what would you tell yourself right now?
Finish what you start.
Okay.
Because I here I am at almost 59, and there are a lot of things that when I was 16 that I didn't finish.
Yeah. That
if I would have finished when I was 16 or 17, it would have been a hell of a lot easier. And I'll give a little bit of an example that I went to UCF. I got a mechanical and aerospace degree from UCF. I started at UCF in '84.
Okay,
I finished in '94. You know, because
that's 10 years for us UF guys.
yeah,
All right.
yeah. So because I got distracted,
Okay.
and I would do something else,
Sure.
and then it's like, oh well, you know, I'll take one semester off for this, and a year shows up.
Right.
And so then the next thing I know is that now I'm working in a catalog that has far more requirements in it than the catalog I started in.
Yeah, yeah.
So if
yeah.
I'd have finished in the 82 or whatever, 84 catalog,
Right.
I wouldn't have to learn half the stuff that I ended up having to learn.
Right.
Because the whole, you know, education and engineering changed so much in that
Right.
extra 5 years because of this stuff.
Yeah.
You know, I started out, everything was on paper.
Right.
So in high school I did paper drafting, in college it was paper drafting. By the time I graduated, if you didn't have a computer and you could do this stuff,
Yeah.
you were behind the curve.
Well, I remember they let us use a calculator, but they made us use a slide rule.
I didn't have to use a slide rule. I could use a
did,
digital
yeah,
slide rule.
Yeah. So,
Yeah. Yeah. We actually had the instructor bring in one of the big educational slide rules, a giant one.
Yeah. Oh yeah.
I said, you know, show us how to do this, and he's over there, you know, like, I'm here trying to remember.
Yeah.
But no, it's that would be just finish it now, and
Okay.
then worry about what's next.
Well, that's good. Well, that is it. Thank you, Kevin, very
Sure.
much. I sure
Yeah,
do appreciate
appreciate it.
everything you've done for this program. Is fantastic. Thanks. That's it for us here from JKE Works, at least for now. I hope you get to be as excited about this stuff. I'm almost 59 as well, as we are when you're our age. So, thanks again. We'll see all you guys later, and thanks, John, for holding the camera steady for all
Yep.
this.
Appreciate it.
Bye.